Hey, you're open here, Kate.
Got a few extra chairs just for a bigger crowd. I guess I got imagine some of the TV people are well, we wrapped up with the tornado watch. Anyway, I guess we'll kick things off. Those of you who don't know me, I'm George Matthews, meteorologist in charge here of the Morristown Weather Office. And thanks for coming this rainy evening. We're going to be talking about tornadoes near Chattanooga, southern part of the area, and other parts too. That happened back in March. Hopefully we won't be repeating that tonight. Although there's a watch over our southern, well, I guess from Knoxville south. So I guess before things start spinning too hard out there, maybe we ought to go ahead and kick things off.
Okay.
I guess real quickly, if we just go around the room and introduce yourselves, just your name and what you do. So introduce myself. Eric, go ahead.
Eric Holing, I'm the ITO here. I'm a meteorologist, but I do the computer work here for now.
Lauren Mars, I'm a retired operational meteorologist from this office.
I'm Dustin Jordan, a recent graduate of meteorology.
I'm Kate Gillette. I'm one of the meteorological interns here at the office.
I'm Jeremy Buckles. I'm a senior in meteorology, and I'm also a school board member in Loudoun County and president of the AOMS this year.
I'm Keith Buckles, and I work at Oak Ridge National Laboratory.
Dave Hodes, Science and Operations Officer here at Morristown, Tennessee. Been here for about 18 years or so.
Brandon Hollingsworth, All Things Considered host at WUOT, which is our NPR affiliate down in Knoxville.
I'm TJ Blasey, I'm a climate change guy at Oak Ridge National Lab.
Howard Waldron, retired WC, I'm here at the office.
All right.
I guess we'll kick it off.
Take it away, Dave.
All right, good. My part is pretty much I'm going to talk about the meteorology and also the radar part of what happened during the March 2nd, 2012 event. Pretty much George and Eric is going to get more into the storm surveys because they did all the pretty much storm surveys afterwards and kind of talk about more of the aftermath of everything. But when it comes to, forecasting and warning really for severe weather, the key word I always try to get our forecasters to realize is situation awareness. And before you sit down on a radar and try to determine what type of severe weather you're going to get, it's always good to know what to expect, or at least have a good feel what to expect. So again, we're going to talk about meteorology, and this right here is just a short, just kind of some shear in the atmosphere. But you take what you learn for the situation awareness, and that's what you can apply to the radar. And then from there, that's when you have the aftermath of these tornadoes, tornado events, or whatever type of severe weather event that you have. So it's kind of a step-by-step process. Okay, the question we have, I want to pose a question to us, is how do we maintain situation awareness of upcoming severe weather events, and what tools do we use, what concepts do we rely upon, and also what kind of parameters do we utilize to look at potential severe weather. Obviously we do have the Storm Prediction Center, and we utilize them a lot. However, I try my best to tell the forecasters don't only rely upon them. We should have our own decision process besides what the Storm Prediction Center is showing. But first I will show you what the SPC, but this is an outlook for around 20 Z's when they put it out for the March 2nd event. And you can tell, a good chunk of our area was under a moderate risk. Parts of the area actually was into a high risk during that day. This is the kind of the probability they had for tornadoes, 15 to 30%. You might think that's kind of low, but really for SPC, that's really pretty high. That's a pretty high probability. When it comes to wind probability, we were kind of approaching or maximizing around 45%. So it had a pretty high confidence we were going to have some damaging winds during this event. And this is kind of the held probability for that same event. Again, it was right around, pegging around 45% or so, or 30%. So they had a pretty good high confidence that we were going to have a pretty large event during that day. But as forecaster here in this office, again, I try to impress on them to look at potential severe weather as more of a kind of inverted pyramid. I'm sorry if I kind of get in your way here. But we kind of look at an inverted pyramid, and what I try to do first is look at more of the synoptic pattern. So what are the low pressure systems? Where are the upper waves moving across? Do these synoptic patterns, do they resemble patterns in the past of, maybe a tornadic type pattern or a severe weather type pattern? We also look at mid to low levels of the atmosphere. Is there a low level jet? Is there an A50 jet screaming around 50 knots? Do you have like shear in the environment? We'll also look for mesoscale, and mesoscale things might be like boundaries. One thing they've determined, I'm sure you guys have heard like vortex, the vortex 1, the vortex 2, and a lot of the different professors out there have done research, as well as people in the Weather Service have done research on what things are more conducive for tornadic environment. And one of the big things they always found out is that boundaries are very important. Not necessarily cold fronts. You're pretty much looking for maybe existing warm front boundary or maybe outflow boundary. These are the type of boundaries that we look for. And the last part of the pyramid is parameters. And when I talk about parameters are things like how much shear is in the environment. We also have different composite parameters like the significant tornado parameter, which we'll talk a little bit more about here in a little bit. But again, the top part of our pyramid is synoptic patterns. And this is really an old a pattern that came out back in the 70s, I guess. What do you think?
78.
78. By who, Howard? Is it Johns?
Lemons, I think.
Is it,
Lemons, I think.
is it Les Lemons or Bob Johns?
Les Lemons was one of the biggies on this one.
Okay. Well, they came out with synoptic patterns, and one of the things you can tell, obviously, is an intense low pressure system. The intense low pressure system, really, these different lines here again, there's isobars. So you can see how the isobars are packing. So you do have a strong low level jet. That's what the LJ stands for. Another thing that's going to stress out to you is this dotted line, SJs, your subtropical jet, PJs, your polar jet. And these two jets come together, and then eventually on this side, they kind of divide out. And that kind of resembles kind of a divergent pattern of the wind flow in the upper levels. Another thing that you have is a deep upper trough. You have a very deep upper trough that precedes a lot of our severe weather events. Not always the case. During the summertime we can have severe weather events without hardly any type of synoptic forcing. But generally for large-scale tornado events, you're going to have a deep upper trough. Okay, this is this is a study that was done by Dave Gaffin, which we all know Dave Gaffin, and also Steve Parker, which Steve Parker used to be our science officer here back in 2005 and later. But they've done some research and looking at synoptic patterns for tornadoes that occur in our forecast area. And one of the things you can tell, this is the surface, and you can tell there's again kind of an intense low pressure system right around Indiana with really tight pressure gradients across the Tennessee Valley. This right here is the 850 millibar level. Again, it's right around 5,000 feet above MSL generally. You can also tell there's an intense low pressure system across the Great Lakes and a really strong tightening of the heights across our area, so really strong winds. This is 500 millibars. Again, this is kind of a composite of all the different events, but you can tell there's a deep, fairly deep trough just to the west of us. And this is 300 millibars. This is kind of represents the wind speed aloft. You can see there's a pretty strong jet associated with this upper trough that's moving across the Tennessee and Ohio valleys. So lots of synoptic forcing with these events. Okay, what we're going to do now, we're going to examine the event. And I'll pop out of the PowerPoint presentation. And let's go. What we've done, thanks to Eric, we was able to pull a lot of the different, the Storm Prediction Center has a nice meso-analysis page, but they archived those events all the way back to 2005. So Eric was nice enough to develop a program for us to be able to grab that stuff and get into our local internet here. So I'm going to look at a couple things, and I think I pretty much got them preloaded. The first one I'm going to look at is, let's see here. Okay, this is actually tornado parameter. I really want to look at that one first. Okay, we're going to look at kind of the upper level pattern. And this right here is water vapor. And this is kind of a loop of a water vapor during the whole process. I want to kind of back up a little bit. But you can tell there's a nice, here's a nice upper trough kind of across this area. One thing about water vapor loop that's really neat, it only looks at really moisture from right around 400 to 500 millibars and above. So it's only looking at moisture right around 15 to 20,000 feet and above. It doesn't look at surface moisture. And if you see this red and black, that represents really dry air. This kind of white and this kind of blue, especially the darker blue, actually represents higher moisture, which is real in this case. This thunderstorm is developing. But one of the good things you can tell about this is, again, you can tell pretty much where the upper level patterns are like. We do have this big upper trough across this area, but also tells where the different jets are. Like here's a jet located right in through here. Here's another jet punching up and through here. So essentially what's happening is you got your subtropical jet. It's kind of the moisture coming out of the subtropics. And then you also got your polar jet, kind of bringing the colder air into the same region. And then between the polar jet and your subtropical jet, you're having this explosive area of thunderstorms. And if I progress forward, you can see how it explodes. And pretty much what's happening here is the winds aloft are just pulling out like this. So you got this big divergence sucking the air up from the top. So that really, you can really see it really well. And another thing that's kind of neat about this too as well is, one thing they found out, and I was talking to Doug Snyder about this, is one of our senior forecasters. They've done research, this is when he's back in Raleigh, North Carolina, that if you could see this red-black air, which is dry air coming from like Mexico and the Texas area, and it kind of pushing into the region, a lot of times it's a situation that's very conducive for severe weather. Okay, let's move on to our next one. All right, this is, so we know we have this big old upper trough. Now I'm going to kind of go down more towards the surface. And what this is, I want to stop it from, this represents, this is theta E values, equivalent potential temperature, which pretty much equivalent potential temperature tells you a sense of moisture and temperature, or almost a sense of instability, really. And earlier during the day, this is kind of like, let's see what time of the day this is. Okay, this is actually right around the morning hours. Let me kind of zoom up here. All right. Might be kind of hard to tell, but okay, here's our neck of the woods. Here's East Tennessee. You see how the winds down here are out of the south, the southwest, and then right through here the winds get pretty chaotic. This right here, right in through here, is a warm front. This is a warm frontal boundary right around daybreak time frame. That's not too far away from down there in southern parts of Tennessee. I don't know why it popped out like that for. Sometimes if you get anywhere close to these smart boards, they're not too smart. They like to pop out. But let's kind of push forward. I better pull out there just a little bit. If you push forward, you'll watch how this bound, all of these southerly winds pull up to the north. Okay, now we're getting like during the afternoon hours into the evening hours. And see how these southerly winds kind of pull right into eastern Tennessee? What's happening is this warm frontal boundary is lifting up across the region. And we knew that during the day. And this warm frontal boundary was a source of increased vorticity and also increased area convergence for producing potential tornadoes. So that was one factor we had to kind of watch out for that day. And initially we had a couple tornadoes across Chattanooga's area, kind of like more like around the noontime, early afternoon. And then we had a kind of a lull period, and then we had some redevelopment, more tornadoes across around the Harrogate area, Middlesboro, up towards Jonesboro, Lee County. So we had kind of like 2 rounds of tornadoes during the day. Okay, and also one thing I didn't represent, this green right here represents moisture. So you can also see how the moisture is pulling to the north. All right. Okay, what this represents what we call CAPE. Let me see if I can stop it here. Okay, essentially what CAPE is, CAPE tells you how much energy is available in the atmosphere. So if you have high levels, high amounts of CAPE, then you have a much better chance of seeing a lot of strong updrafts in the storm. And in this case here, let's kind of pull back a little bit. You can kind of see early during the day, our values of potential energy for thunderstorm development was really pretty low. It's right around less than 250 joules per kilogram. But during the day, as you progress forward, you can kind of see it kind of move up towards our area. Now we're kind of getting right around about 1,000 joules per kilogram. So we can kind of see this warm, moist air pulling up. But overall, really, for a big tornado outbreak, 1,000 is really, not a big high number for really tornado development. Okay. Next thing I was going to show, this is what we call lifting condensation level. I'm going to kind of explain this a little bit.